Let's talk about Microsoft Agent Framework, a framework that's fundamentally changing how we develop enterprise multi-agent AI systems. Let me first start with what AI agents actually are, especially if you're new to the space. An AI agent is a software system that uses a large language model to make decisions autonomously. Think of it as giving an LLM and the ability to take actions, not just generate text. The agent can call tools, query databases, invoke APIs, and chain multiple operations together to accomplish a goal. Let me outline what we are going to cover today so you know exactly what to expect. First, we'll discuss what Microsoft Agent Framework actually is and why Microsoft created it. This matters because understanding the motivation helps you make superior architectural decisions later. Second, we'll dive deep into the core architecture, specifically the difference among individual agents and workflows. This distinction is essential because choosing the wrong approach can lead to unnecessary complexity or missed capabilities. Third, we'll explore 5 orchestration models for multi-agent systems. These models solve different challenges. Knowing which model fits your specific use case can save you weeks or months of development time. Fourth, we'll examine model context integration, which is how agents connect to external tools and services. This is the extensibility layer that makes agent viable in enterprise environments. Fifth, we'll cover Azure AI Foundry deployment. This is where the local to cloud story truly shines. You can develop agents locally using Microsoft Agent Framework and then deploy to the cloud on Azure Foundry Agent Service without rewriting your code. Sixth, we'll examine observability and governance features as well. In my experience, these enterprise requirements are often afterthoughts, yet Microsoft Agent Frameworks includes them from day one. And finally, we'll discuss open standards, migration strategies, and actual use cases. You'll see how companies like KPMG are already using Microsoft Agent Framework in regular industries that they serve. Now let's dive deep into what Microsoft Agent Framework actually is. So Microsoft Agent Framework was actually launched in October 2025 and is currently in its initial release. Now you might wonder why we need another framework when we already have Semantic Kernel and AutoGen. Let me explain the core definition and the challenge it solves. Microsoft Agent Framework is an open source SDK available for .NET and also for the Python language. What makes it unique is that it unifies Semantic Kernel, which was created for enterprise systems, with AutoGen, which came from Microsoft's advanced release and focused on experimental multi-agent orchestration. Each framework has dedicated user communities, yet each had gaps. The teams creating them kept hearing from developers asking why they couldn't have the innovation of AutoGen and the trust and stability of Semantic Kernel in one unified framework. That's exactly what Agent Framework aims to deliver. Here's the critical aspect. It's created by the same two teams that develop Semantic Kernel and AutoGen. This isn't the third team that's trying to merge these two code bases. So these teams essentially know the strengths and weaknesses pretty closely, and they have created what is effectively the next generation of each framework, which is Microsoft Agent Frameworks aim to solve. The first major issue is the fragmentation across the development lifecycle. Developers would create initial concepts with one framework and then face a complete rewrite when they're trying to move to deployment with different requirements. Agent Framework eliminates this situation through a single framework that works from experimentation through full deployment. Second, there's the context switching challenge. Study shows that 50% of developers lose more than 10 hours weekly due to the inefficiencies like fragmented tools. When you're jumping across different frameworks with different APIs and different mental models, that cognitive overhead accumulates over time. Third is the enterprise readiness. Most open source frameworks treat observability, security, and compliance as add-ons that you have to create yourself. Microsoft Agent Frameworks includes these from day one. For example, there's OpenTelemetry integration, Azure AI Content Safety, Entra ID authentication, and structured logging are all there included in the core framework. What this means is that the actual usage is pretty straightforward. You can experiment locally with full confidence that the same code, the same fundamentals, and the same models will work in the cloud. There is no gap across what works on your laptop and what works at scale in deployment. Next, let's examine the core architecture and understand how agents and workflows differ. Understanding the distinction across AI agents and workflows is fundamentally important to using Microsoft Agent Framework effectively. These serve different needs and operates at different levels of abstraction. Let me start with AI agents, which are individual autonomous components. AI agents are LLM driven, meaning they use large language models to make decisions about what to do next. They have tool access via MCP servers, so we'll deep dive into model context layer later. Yet for now, think of it as a standardized way for agents to call external tools and services. The key characteristics of agents is autonomous decision making for unstructured tasks. When you have a challenge where the exact sequence of steps is not known in advance, where you need to do trial and error exploration, or when you're dealing with conversational interfaces, that's where agents are ideal to use. Agent framework supports multiple model vendors. So, for example, you can use it with Azure OpenAI, OpenAI's native models, or Azure AI Foundry as well. This flexibility means you're not locked into single vendor's models because you can use open source models like Llama by Meta or Mistral models through Azure AI Foundry. Now, here's an essential consideration about when not to use individual agents. If you can write a deterministic function to solve your challenge, do that instead. Agents introduce non determinism and latency. They're highly effective tools, yet they are not the ideal tool for every job. Now, let's discuss workflows, which handle multi agent coordination. Workflows in agent framework are graph structured with deterministic execution sequences. While individual agents are LLM driven and make their own decisions, workflows define the structure: which agent runs when, how data flows across them, and how outcomes are aggregated. The workflows are type safe with validation and execution time. This is pretty significant for deployment systems. The framework validates your workflow graph at the creation time, checking that message types are compatible across connected components, that all agents are reachable, and that there are no invalid edge configurations. This catches errors during development time instead of at the execution time when it's in the production. Workflow supports several critical features. For example, checkpointing allows users to save state and continue long duration tasks. This is pretty important for workflows that might take hours or even days. Human in the loop models let you halt a workflow and get human approval or input and then continue. Concurrent execution lets multiple agents work simultaneously when tasks can execute them in parallel. So, when should you actually use agents versus workflows? You should use individual agents for exploration for challenges where you need the flexibility of LLM driven decision making, and you should use workflows for coordination when you have multiple agents that need to work together in a structured way or when you need guarantees about execution order and state management. In actual usage, you'll often use a combination of both. Workflows that orchestrate multiple agents, each of which uses LLM intelligence for their specific aspect of the challenge. Now that we understand the architecture, let's explore the 5 orchestration models you can use for your multi-agent systems. Microsoft Agent Framework offers 5 core orchestration models. Each model solves a different coordination challenge. Choosing the ideal one significantly impacts your system's effectiveness. Let me walk you through the first 3 models. Model number 1 is sequential orchestration. In sequential orchestration, you organize agents in a sequence where each agent handles the tasks in turn. The output of one agent transforms into the input of the next agent. This is ideal for workflows where each step develops from the earlier one. When should you use the sequential orchestration? Consider document analysis workflows where you need summarization, then translation, then quality assurance in that exact order. Or data handling sequences where you have to extract, transform, and then load. Or you can consider multi-stage intelligence where you have to gather information, then analyze, and then synthesize. The key characteristic here is a dependency. Each step depends on the completion of the earlier step. You can't execute them in parallel since step n needs the outcome from step n minus 1. Now, moving to model number 2 is concurrent orchestration. Concurrent orchestration enables multiple agents to work on the same task simultaneously. Each agent handles the input independently and the outcomes are collected and aggregated at the end. This model works well when you want to diverse viewpoints on a challenge. For example, in ideation sessions, you might have multiple agents each generate different ideas, then synthesize them, and then you base your analysis on that result. In assembly intelligence, you might have several agents that each analyze the challenge using different approaches and then vote or combine their conclusions, let's say by approach like LLM as a judge. The critical difference from sequential is that these agents work at the same time. None of them depend on the other's outputs. This can significantly reduce total latency. So if you have 3 agents that each take 5 seconds, sequential orchestration takes 15 seconds while concurrent only takes 5 seconds. Now for model number 3, which is group chat orchestration. Group chat orchestration is designed for collaborative conversations. You have multiple agents along with the manager who moderates the discussion. This can even include humans in the loop. Think of this like simulating a meeting. You might have agents with different viewpoints: engineering, strategy, legal, each with their own outlook. The manager agent moderates, decides who speaks when, and who can introduce a human decision maker at a critical point. Use cases include meetings where you need different viewpoints, discussions where you want the agents to challenge each other's logic, or collaborative exploration where the solution emerges from discussion instead of individual analysis. The manager's role here is pretty important. Without good moderation, group chats can drift off topic or can get stuck in loops. The manager needs to identify when consensus is achieved or when human intervention is needed. Next, let me show you the final two models which handle more complex scenarios. Now let's cover the final two orchestration models. These handle more dynamic and complex scenarios. Model number 4 is handoff orchestration. In handoff orchestration, the lead transfers across the agents depending on the evolving context. Each agent handles a segment of the task that matches the expertise and then hands off the suitable next agent. Here's what makes this pretty effective. The ideal agent handles a suitable task segment at each stage. You're not forcing a single agent to handle everything. Instead, you have a specialist agent and direct the work to whoever is more qualified for that particular task. So, when should you choose handoff orchestration? Customer support is a classic case. A general support agent can handle the initial inquiry. If it's a technical question, then they hand off to the technical expert. If it's an account or billing related, then you hand off to the account specialist agent. Each handoff includes the context so that the next agent can continue seamlessly. Expert systems gains from this model too. You might start a general diagnosis and then hand off to a domain specialist as you narrow down the challenge. The key is dynamic delegation. The decision about who receives the handoff happens during execution depending on the conversation context and not determined in advance. Now, for model number 5 is magnetic orchestration, which is designed for the most complex scenarios. Magnetic orchestration is specifically for open ended challenges that don't have a determined execution sequence. You have a manager agent that creates a dynamic task ledger, coordinating specialized agents and sometimes humans as the challenge evolves. And here's how it works. The manager interprets the user's goal and divides it into initial subtasks. As specialist agents work on these tasks, the manager monitors their advancement. Depending on the outcomes, the manager dynamically updates the task ledger, adding new tasks, removing obsolete ones, or even resequencing the tasks. The focus here is as much as on creating the approach as implementing the solution. So when should you consider magnetic orchestration? You should use magnetic orchestration for complex challenges without a determined execution sequence. If you can't map out all the steps in advance, if the ideal approach only emerges as you gather more information, or if you have a challenge that needs iterative refinement, magnetic orchestration gives you that flexibility. For example, investigative analysis task where you don't know what information you will need until you see the initial outcomes. Or comparative analysis where the suitable questions depend on what you discover. Or even a strategic decision where the course forward emerges from the initial analysis. The manager's role here is pretty sophisticated. It's not just directing, it's designing, adapting, and orchestrating multiple agents whose contributions develop from each other's in a way that won't be knowable at the time of start. One essential caveat is there. Magnetic orchestration has more overhead than the other models. The manager agent needs to think about task structure, dependencies, and advancement. For well defined challenges, simpler models are pretty sufficient. Yet for truly open ended challenges, this overhead is worth the flexibility. Now let's discuss how agents actually connect to external tools through Model Context Protocol. Model Context Protocol, or MCP, is a standardized way that agent framework connects agents to external tools and services. Understanding MCP is pretty important since it's the extensibility mechanism that makes agents viable in actual systems. It was developed by Anthropic and now is being adopted across the industry. So let me start with what MCP actually offers. MCP is an open standard that defines how applications give tools and context to large language models. The key word here is standard. This is not a specific vendor-specific Microsoft convention. It's actually designed for consistent, scalable integration of external tools into model workflows. And it was developed initially by Anthropic, and now it's open source and is widely being adopted by all the big AI companies, big cloud providers, for example, Amazon, Google, Microsoft, and more. What makes this effective is the dynamic discovery aspect. Agents can dynamically discover what tools are available from an MCP server, understand what those tools do, and invoke them without you writing customer indication to code for each tool. The MCP server exposes a manifest that describes available tools, the input requirements, and the output types, and agents can use this information to call tools suitably. Now let's discuss common MCP servers you'll encounter. You'll find MCP servers for common operations, for example, calculator for mathematical computations, file system for file operations, GitHub for code repository access, SQLite for database operations, yet the actual strength is the custom APIs. You can wrap your organization's internal APIs as MCP servers, make them instantly available to any agent. The ecosystem is growing pretty fast. The third party vendors are publishing MCP servers for their services, so the library of available tools expands without framework changes. Now, here's what makes agent frameworks MCP integration work in two directions. Agents consume tools via MCP clients. This is a common use case. For example, your agent needs to execute some action. It discovers an MCP server that offers that capability and it calls the tool. Yet agents can also expose themselves as MCP servers using the as MCP server method. This means an agent you create can transfer into a tool that other agents can use. Even agents created with different frameworks can support that. This creates composition models where sophisticated agents transform into components for even bigger, more sophisticated systems. For enterprise deployment, Azure Foundry hosts managed MCP with significant advantages. The MCP servers are hosted and managed through Azure, so you don't need to maintain the infrastructure yourself. You get configurable approval workflows for tool integrations. This is pretty important in regulated environments where you need human sign off for certain actions. And you also get enterprise security with authentication and network isolation as well. In my experience, this approval workflow feature is pretty important for deployment systems. You can configure tools as always approved for low consequence operations and always needing approval for the high consequence operations, which are super important, or they are, let's say, supporting clients in government scenarios or like DoD, for example. For instance, a database query tool might auto-approve select statements, yet they need approval for delete or update operations. Now let's examine how you actually deploy agent framework applications to Azure AI Foundry. One of the agent framework's key strengths is the seamless local to cloud deployment story. Let me walk through how this works in actual usage. The local to cloud journey starts with experimentation. You develop locally with full agent framework capabilities, all the orchestration models, all the tools, complete observability, and then you can iterate quickly, debug interactively, and refine your agents without cloud dependencies. When you're set to deploy, you use the same fundamentals. There is no rewrite. The agents you tested locally on your machine, the workflows you validated there, the MCP integrations that you already configured, they all work in Azure AI Foundry without any modification. So what occurs during deployment? You get automatic instrumentation and telemetry. The agent framework automatically wires in open telemetry tracing, Azure Monitor integration, and structured logging. You don't need to add these different services separately. It's enabled through the deployment itself. Now let's discuss Foundry Agent Service, which is a managed execution environment. Foundry Agent Service is a fully managed execution environment for agents and workflows. You get state that remains across executions stored in Cosmos DB. This is customer controlled, meaning you manage the database, the recovery strategies, and the geographic configuration. Geographic failover with state continuation is pretty included as well. If your initial geographic location becomes unavailable, agents automatically connect to the Cosmos DB in your configured secondary location. Since all state is in Cosmos DB, agents continue with full context. That means there is no loss of conversation history or workflow advancement. The VS Code extension is highly effective for the development workflow. You can create, test, and deploy entirely from your IDE, so no context switching to web interface is needed unless you want to see deployment dashboards or execute administrative tasks. Let me mention the integration capabilities since this is where the most amount of enterprise value truly comes from. You get 1400 plus connectors through Azure Logic apps. That means your agents can now interact with Salesforce, ServiceNow, SAP, or virtually any enterprise system without writing custom integration code. Microsoft Graph offers access to emails, calendar, SharePoints, and Teams. All the Microsoft 365 services that contain your organization information are now essentially available to you. Microsoft Fabric actually then gives you the access to data warehousing, data engineering, and analytics in real time. And then you have the full Azure AI model catalog available to you as well, which includes models like GPT-4, GPT-5, Llama model by Meta, Mistral, or any of your own fine-tuned models. You can direct different agents to require different models depending on their requirements. You can use a small, fast model for simple decisions and a large, capable model for complex intelligence. This flexibility matters in deployment. You're not locked into one model for all your agents. You can optimize cost versus capability for each agent, and you can switch models as new ones emerge without changing your agent code. Now let's discuss the observability and governance features that make this deployment ready. Enterprise systems need observability and governance from day one. Agent Framework takes this pretty seriously, so let me show you what's included. Starting with OpenTelemetry integration, the framework instruments every agent action, every tool call, every orchestration step automatically. You get distributed traces that show the complete execution flow across all your agents in a workflow. This is pretty important for investigating multi-agent systems where understanding why something occurred needs to see the full conversation history and decision sequence. For example, when you're investigating a bug or maybe a life-side incident. The traces include full execution context. You can see what the agent got as input, what tools it called with what inputs, and what those tools gave back, and then what the agent decided to do next. In my experience, investigating deployment issues, having this level of detail is pretty important, and it makes a difference from a 5 minute investigation to, let's say, a multi-hour investigation where you're spending lots of time debugging. So what's effective is that this works across multiple frameworks. The OpenTelemetry integration works whether you're using Agent Framework, LangChain, LangGraph, or the OpenAI Agents SDK. If you have agents created with different frameworks collaborating in the same workflow, you still get unified traces. The traces flow into Azure Monitor application, so insights are there automatically where you can create custom dashboards, configure alerts for anomalies, and analyze trends across time. Now let's discuss the AI safety features, which are pretty important as well. Task adherence helps keep the agents focused on their assigned goals. Agents can then engage conversationally, which is pretty important, yet they also sometimes wander off topic or can get manipulated into doing things outside their scope. Task adherence monitoring defects when agents deviate from the intended focus. So, safety shields with spotlighting defense against the injection attacks. These attacks try to trick the agent into ignoring its instructions and following attacker supplied instructions instead. Spotlighting highlights the suspicious elements in the user's input, and safety shields also stop the known attack vectors. Sensitive data detection identifies and manages the confidential information automatically. If an agent gets sensitive information like a social security number, credit card number, or home addresses, the detection can flag it, remove it from logs, or stop it from storage depending on your configuration. The AI safety testing agent uses a tool from Microsoft Security. This agent systematically tests your AI system for safety concerns. For example, can it get manipulated into generating harmful content? Does it leak the training data? Can it get made violate its safeguards? The analysis tracks improvements across time so you can measure whether your mitigation is effective or not. For compliance and security, you can enterprise grade authentication and authorization through Entra ID along with role control access. Virtual network integration allows for isolated deployment where agents never touch the internet. Content safety integration offers real-time content moderation for inputs and outputs, stopping violence, self-harm, hate speech, and adult content depending on your configure thresholds can be filtered out. In regular industries like healthcare or finance, these features are not optional, they're actually very important to implement. Having them included in the agent framework instead of creating your own custom solutions will save you many weeks and even months of development time. Next, let's discuss the open standards and how Microsoft Agent prevents the vendor lock-in problem. So Microsoft Agent Framework was actually created with open standards at its core. Let me explain what that means for flexibility and ecosystem integration. Starting with Model Context Protocol, which we discussed earlier, MCP allows your agents to dynamically discover and invoke tool servers without writing connection code for each integration. This critical aspect is that the MCP is an open standard and it's not vendor specific. Tools offered as MCP servers work with any MCP compatible client, not just Microsoft Agent Framework. The ecosystem of MCP compatible services is growing pretty fast. Third parties are offering MCP servers for their systems. This network effect means your agents gain new capabilities as the ecosystem expands without framework updates. Agent to agent or A2A offers structured messaging across execution environments and frameworks. And here's why that matters. You might have one agent executing an agent framework, another agent in LangChain, and a third agent created with a completely different framework. A2A allows them to collaborate through structured, convention-driven messaging. They don't need to exist in the same environment, same language, or even same cloud vendor. A common arrangement is having one agent fetch in data, another analyze it, and a third validate the outcomes. With A2A, these agents can then independently be deployed and maintained through different teams, yet they collaborate as if they're part of the same single system. So OpenAI first design is actually pretty important here. Any web API that has an OpenAI API specification transfers into a collab tool instantly. You don't need to write the adapter code. The framework consumes the OpenAPI specification, understands the endpoints, inputs, and output formats, and then can call those APIs on the agent side. This dramatically reduces the integration work. If your organization already has APIs with open API specification, which most modern APIs do, those APIs are immediately then available to your agents. Now let's discuss the connector ecosystem and memory options. For included connectors, you get Azure AI Services, Microsoft Graph for Microsoft 365 data, Microsoft Fabric for data systems, SharePoint for document storage, and MongoDB for document databases. These connectors are actually maintained through Microsoft and are updated pretty regularly. For memory stores, Agent Framework actually supports multiple vector databases and conversational memory systems. Redis, Pinecone, Elasticsearch, and the database system with vector integration are all worked through the memory interfaces. So you're not locked into a single vendor. This part is pretty important because different vector databases have different strengths. Some optimize for speed, some optimize for memory efficiency, and some optimize for accuracy. Having the ability to choose means that you can optimize for your specific business requirements. If you already have infrastructure in any one of these systems, you can actually leverage the existing investment. If you need to migrate one to later, the Microsoft Agent Framework actually lets you enable that. So in my experience with enterprise systems, this interchangeability is pretty important. Vendor selections change, costs change, capabilities change. Having the ability to swap implementations without rewriting the application code offers pretty significant flexibility, which is pretty important for long-term maintenance. Now let's discuss the migration strategies and customer adoption. If you're currently using Semantic Kernel or AutoGen, you're likely wondering about migration. Let me explain the strategies and show you how to actually adopt to Microsoft Agent Framework then. Let's start with talking about migration from Semantic Kernel. The migration is designed to go smoothly since Microsoft Agent Framework is the evolution of Semantic Kernel, created by the same Microsoft team. Native thread management is included. Agents manage conversation threads natively without separate thread objects. Tool registration is inline without attributes or add-on wrappers, which simplifies the development experience. Your existing vector stores can continue to work as usual. If you're using Azure AI Search, the database system with vector extension, or Cosmos DB or Redis, those integrations should work without any modification. The storage layer abstraction is compatible as well. Add-ons convert directly as tools. Your Bing Search add-on, Google Search add-on, OpenAPI add-ons, Microsoft Graph add-ons, they all transform into tools in Microsoft Agent Framework with minimal changes, often just namespace updates. The migration guide in the documentation offers step-by-step instructions with code examples. Most single agent applications can migrate in hours. Multi-agent applications can take longer since you might want to adapt to the new workflow abstractions, yet the core migration is pretty mechanical. Now let's talk about migration from AutoGen. AutoGen introduced many orchestration models, and those models are now unified in the Microsoft Agent Framework under the workflow abstraction. Group chat transforms into the workflow with group chat orchestration. Group flow transforms into a workflow with custom directing logic. So these concepts actually translate directly. Assistant agent maps to chat agent. The difference is that chat agent is multi-turn automatically and handles tool invocation automatically until an outcome is ready. You don't manually manage the conversation loop. Function tool wrappers migrate to the AI function decorator. AutoGen needed explicit tool wrapper objects. Agent Framework uses these decorators for cleaner syntax with automatic schema inference. Messaging is simplified here as well. AutoGen had multiple message classes for different scenarios. Agent Framework now uses a unified chat message type with explicit roles: user, agent, tool, and system. This reduces the conceptual overhead. Orchestration shifts from event-driven models to typed, graph structure, and workflow APIs. AutoGen's event-driven approach was flexible yet could get pretty hard to think about. The workflow graph actually gives you the explicit control with visualization and investigation support. Now let me show you the actual customer adoption since this validates the Microsoft Agent Framework's readiness. So from the Microsoft Agent Framework's website, it's shown that there are multiple enterprise companies already using it. So for example, KPMG created an agent system called Clara AI for audit, automation, in regulated industries. So this is pretty important. Auditing is pretty heavily regulated with strict compliance requirements. KPMG chose the Microsoft Agent Framework since the governance and observability features are included from day one. The open source connectors allowed the Clara AI by KPMG to work with Azure AI Foundry as well as external systems, enabling scaled multi-agent collaboration across their global enterprise. Next, TCS, which is Tata Consulting Services, is using Agent Framework for enterprise-grade solutions across multiple industries and functions. They're leveraging the flexibility to create diverse applications with the assurance of deployment-ready foundations. Companies like Sitecore is developing a solution that let marketers interact with their systems through intelligent agents. These agents can automate the tasks across the entire content supply chain, from creation to managing web experiences to handling digital assets. They are using the Microsoft Agent frameworks and supports fully non-deterministic agent orchestrations for creative tasks and deterministic agents for structured workflows. The customer Elastic, which is behind Elasticsearch product, is actually offering a native connector across Elasticsearch and Microsoft Agent framework. Elasticsearch is their context engineering system and vector database. With the connector, developers can introduce organizational context directly into the intelligence agents and multi-agent workflows, combining the intelligence of agents with Elasticsearch speed and scale. From the Microsoft Agent Framework's website, over 70,000 organizations are currently using this framework, which is the deployment system for their multi-agent systems. Now, let's talk about key takeaways and when you should actually use the Microsoft Agent Framework. Now, you should use the Microsoft Agent Framework when you're creating multi-agent systems that need orchestration. If you have complex tasks that gain from multiple specialized agents working together, the orchestration models and workflow capabilities give you the structure you need without reinventing the coordination logic. You should use the agent framework when you need enterprise observability, security, and compliance. If you're creating for deployment instead of experiments, having open telemetry tracing, content safety, authentication, and audit logging from day one actually accelerates your development time pretty significantly. You should consider using Agent Framework when you want the local experimentation with a clear deployment sequence. The ability to develop and test locally with confidence that the same code will work in Azure AI Foundry and actually in the cloud actually eliminates the major source of deployment concern. The fourth reason to consider using Agent Framework is that for complex workflows that need checkpointing, for example, human in the loop approvals or state management, these models are surprisingly hard to implement correctly. Having them included in the framework as tested fundamentals is pretty important. Comparative advantages that Microsoft Agent Framework offers. First is that it's a unified framework. You don't choose across innovation and enterprise stability, and you don't have to make the trade offs. You get each of them. So, for example, AutoGen's flexibility for experimentation combined with the semantic kernels, enterprise, and deployment ready foundation. Second is the local to cloud consistency. Using the same fundamentals from development through deployment reduces the friction through approximately 50% according to developer surveys. So there is less cognitive overhead from switching frameworks or rewriting the code. Third is the multi-framework observability. The open telemetry integration works whether you're using Agent Framework, LangChain, LangGraph, or OpenAI SDK. If you have a mixed ecosystem, you can still get the unified visibility. Fourth is the Microsoft ecosystem integration. Deep integration with Microsoft 365, Azure Services, Entra ID, and Fabric means reduced integration work if you're already in the Microsoft ecosystem. From an architecture view, you should use individual agents for unstructured, exploratory, or conversational tasks where you need the flexibility of LLM-driven decision making. You should consider using workflows for complex multi-step enterprise tasks that need the coordination across multiple components with guaranteed execution order and state management. So that was our deep dive on Microsoft Agent Framework. If you have any questions, please let me know. Thank you.